Voyager 2 and the Whisper in the Void, a mysterious signal from interstellar space. More than 4.5 decades since it first left Earth, Voyager 2, one of humanity's most iconic spacecraft, is still astonishing us. Launched in 1977 on what was originally envisioned as a grand tour of the outer planets, the spacecraft has long since transcended its initial mission. It now sails through the interstellar medium, the cold, enigmatic space between the stars, transmitting whispers of a realm no human-made object has ever directly explored. And now, Voyager 2 has detected something truly unexpected, a stable low-frequency signal, a strange 3 kHz tone echoing through the cosmic emptiness, raising fundamental questions about what may truly lie beyond the heliosphere. This development, mysterious and thrilling in equal measure, reminds us that the Voyager mission is far from over. Though powered by aging systems and barely sipping electricity from its steadily depleting radioisotope thermoelectric generators, RTGs, Voyager 2 continues to challenge our assumptions about the cosmos. It continues to surprise us not just with its longevity, but with the nature of what it's encountering in interstellar space, a region once thought to be silent, still, and devoid of surprises. A journey beyond time and expectation. In the 1970s, few could have imagined that the Voyager probes, Voyager 1 and Voyager 2, would remain operational in the 2020s, let alone continue delivering groundbreaking science. Originally tasked with planetary flybys, they have far outlived their expected lifespans. Voyager 2, now over 20 billion kilometers, more than 12 billion miles, from Earth, has entered an area beyond the heliopause, the boundary where the sun's solar wind is no longer strong enough to push back the interstellar medium. It's not just distance that makes Voyager 2's journey astonishing. It's the sheer resilience of the technology. Designed with 1970s electronics, its systems have been kept alive through ingenuity, creativity, and relentless patience from NASA engineers. Every signal exchanged requires nearly 20 hours of travel time each way. Communicating with Voyager 2 today is like talking to a ghost in deep space, one that answers in faint but profound whispers. And one of those whispers is now grabbing scientists' attention in a way that few other space discoveries have in recent years. The 3 kHz mystery, a signal in the silence. For more than 3 years, Voyager 2 has detected a stable signal at 3 kHz, a frequency that should not exist in such a place. Deep in interstellar space, where there is no atmosphere, no planets, no magnetic fields from stars, this frequency has been observed as persistently consistent and strangely clear. Unlike the noisy, chaotic data usually seen in space plasma measurements, this signal is ordered and steady. It has led scientists to speculate whether this could be more than just a natural phenomenon. Some hypothesize that this frequency may originate from plasma oscillations, caused by the motion of charged particles like electrons in the interstellar medium. Indeed, plasma is the dominant state of matter in the universe, comprising most of the interstellar material. However, the stability and duration of this signal, lasting for over 3 years, suggests something else. Plasma-generated noise typically fluctuates. It waxes and wanes, modulated by changes in density, temperature, and local magnetic fields. A signal as steady as this, in contrast, hints at either a technological origin or an unknown astrophysical mechanism with properties we do not yet understand. Could this be a case of Voyager 2 picking up a deliberate transmission, a signal from an alien civilization? Or is it perhaps an entirely new kind of natural resonance in the interstellar medium, one never before observed or predicted? What lies between the stars? The interstellar medium is often misunderstood. While we might imagine it as empty, it's actually filled with tenuous clouds of ionized gas, magnetic fields, and dust, stretching across the cosmos like a vast, invisible ocean. The plasma that pervades this space is mostly made of ionized hydrogen and helium, with a smattering of heavier elements. This material is incredibly diffuse, often just 0.1 to 10 particles per cubic centimeter, but it is far from inert. Voyager 2's transition into interstellar space revealed shocking surprises. Most notably, The probe measured a 40-fold increase in plasma density compared to expectations. This dense layer, sometimes referred to as the plasma wall at the boundary of the heliosphere, suggests the edge of our solar system is not just a simple transition, but a dynamic interface between solar and galactic forces. Such a dense plasma environment could conceivably act as a waveguide, allowing certain frequencies, like the 3 kHz signal, to propagate far more efficiently and stably than expected. But even if the medium helps transmit the signal, it does not explain the source. Artificial or astrophysical? If the signal has a technological origin, the implications are staggering. A stable 3 kHz signal in the absence of any known natural source could indicate a transmission from an extraterrestrial intelligence, perhaps even an ancient beacon, left adrift in the galactic dark, awaiting detection. Such a signal would need significant energy to maintain stability across such vast distances and through the turbulent interstellar plasma. But even if not artificial, it may still be revolutionary. The signal might be revealing a new kind of astrophysical process, perhaps related to magnetic reconnection events, cosmic ray interactions, or unknown plasma wave dynamics. Voyager 2 might be detecting a phenomenon that, while natural, has never before been directly observed because no other instrument has ventured so far into the void. A lifetime of discoveries. Voyager 2 continues to send data using its limited power reserves, with engineers at NASA painstakingly deciding which instruments to keep alive. Its plasma wave subsystem, one of the few still operational, is a key player in detecting these low-frequency interstellar signals. Every byte of data it sends helps scientists map the unknown territory between the stars, a place that has shaped galaxies and stars for billions of years. Even small fluctuations in particle density, magnetic fields, or wave activity are gold mines of information. They inform not just our understanding of our own solar system's boundaries, but also the astrophysical processes that shape the structure of galaxies. Troubles and triumphs. Voyager 2 in the 2020s. Despite its age, Voyager 2 continues to overcome adversity. In 2023, a communication error caused the spacecraft's antenna to shift just 2 degrees, a seemingly minuscule angle that severed contact with Earth for weeks. Engineers used the Deep Space Network, particularly the large antenna in Canberra, Australia, to painstakingly re-establish contact. Each command took 18 hours to reach the probe, and just as long for a reply. But after weeks of suspense, contact was restored. In 2024, garbled data once again caused concern. The clarity of transmissions dropped dramatically, and the cause remained unclear for weeks. NASA engineers believe the issue stems from aging memory systems, with corrupted command sequences being generated or improperly interpreted due to radiation exposure and bit rot. Despite this, remote commands managed to stabilize the probe once again, another testament to the simplicity and durability of 1970s-era engineering. The future of Voyager 2. Voyager 2 will not last forever. Its RTGs lose about 4 watts of power per year, and it's expected that by the early 2030s, power levels will drop too low to maintain contact. Instruments will shut down one by one until the probe can no longer send data, and then silence. But even after contact is lost, Voyager 2 will continue on its journey. Coasting through the Milky Way for millions, perhaps billions, of years. It carries with it the golden record, a message from humanity etched in metal, bearing music, languages, and images of life on Earth. A time capsule adrift in the stars. The legacy of the whisper. Whether the 3 kHz signal is a natural plasma resonance, a hidden force in the galaxy, or something far more exotic, Voyager 2 has once again pushed the frontier of human knowledge outward. With each byte of data it sends home, it reminds us that curiosity transcends time, that even aging machines can uncover eternal mysteries, and that the universe still holds secrets waiting to be discovered. In a future when our descendants look back at the first steps humanity took into the interstellar void, Voyager may second stand as our first true messenger to the stars, a traveler not just of space, but of time.